Good morning, students. This is your third lecture for the subject Metrology and Quality Control. In first two lectures, we have covered the basics of metrology. That is, what is the meaning of metrology. Then, these are the principles of metrology. Then, necessity and importance of metrology. Then, we also discuss what is quality control and what is the relationship between metrology and quality control. Then, this is the 5-step method for quality control techniques. These are the objectives of metrology. There are total 8 objectives. Then how the process of measurement is takes place with the help of 3 parameters like measurement, reference and comparator. Then we see there are two different methods of measurement. First is your direct method and second one is your indirect method. Then we see a measuring system, 5-step measuring system like your quality control. This is also include 5 step, 5 elements: standard, workpiece, instrument, person and environment. Now, in the last lecture, we were come to this point due to network failure. That part of accuracy and precision was not explained well. So I again explain this concept. So first of all, we see what is accuracy. Then we will see what is precision. So accuracy is defined as closeness of the measured value with true value. Means suppose in your if you are working in the industry and you have to measure a value of a particular object which is manufacturing in your plant. Suppose you are going to manufacture a particular uh, like a pen manufacturing industry in which you are producing 10,000 pens per day. So each and every time you are not going to measure the actual value of this particular dimensions of that particular pen. So in that case, accuracy and precision data will help you to calibrate to find out for the inspection purpose, for the generalized inspection purpose. Okay, that the product is made within the limit or not. So for the inspection, we must have knowledge of accuracy and precision. Okay, so first we'll see what is accuracy. Accuracy is defined as the closeness of the measured value with true value. Suppose you are going to manufacture a 10 mm diameter pen, that is 10 mm is your true value, and if you are getting value 9.99 mm, 9.98 mm, 9 10.10 mm, so this value is very close to your true value, that is 10 mm. So that's why these values are accurate. Okay, see, again here it is explained as accuracy is defined as the degree to which the measured value agrees with the true value. Okay, so degree of accuracy which is related, which is near the value which is very nearer to the true value of your object. Okay, but practically it is very difficult to measure the true value, and therefore a set of observation is made whose mean value is taken as the true value of the quantity measured. Okay, but practically it is not possible, so we always take a mean value for your quantity to be measured. Then second thing is your precision. So what is meant by precision? Precision is a measure of how close repeated trials are to each other. Means the closeness of repeated measurements. Okay. In accuracy, we find the value which is very nearer, which is very closer to the true value. But in case of precision, if we measured 100 number of pens and we are getting the repeated value, some value is continuously repeated, like suppose 9.89 mm value is repeated again and again, again and again, again and again. So that is the precise value for the particular pen. Okay, and your accuracy is very the close value of nearer to the true value. Okay, so that is the basic difference between accuracy and precision. Okay, the precision is the repeatability of the measuring process. It refers to the group of measurement for the same characteristic taken under the identical conditions. Means the value which repeat continuously when the group of measurement is taken under the identical conditions, means the working conditions are same. Okay, and a single person which is measuring that value. So this value will be different when the other person measures this value. Okay, so for same condition, the value is repeated, then it is called as the precise value. Okay, it indicated to what extent the identically performed measurement agree with each other. If the instrument is not precise, it will give different result for the same dimension when measured again and again. So if your instrument is not precise means if your instrument is not showing the repeated value for the same thing, then this means that your product is not manufactured wrongly, but the measuring device is failure. So precision also helps to calibrate the performance of your instrument. Okay, so this is the difference. So just keep one thing in your mind. Accuracy means what? Accuracy is the degree of closeness to the actual value, and precision is the repeatability of some value. Okay, see, we will see the distinction between precision and accuracy by this diagram. So here you are given four different diagrams. One is here. Okay, just 1 minute. See, A, B, C, and D. There are four conditions. See, here your we will see the statement. Okay, figure shows the difference between the concept of accuracy versus precision using a dashboard analogy that shows four different scenarios that contrast the two terms. Okay, see in diagram A, three darts hit the target center and are very close together. Okay, so here this is your target lines, and you are hitting this target with the help of your gunshots. Then these three darts, every time we are firing three bullets. Okay, so every time we are firing three bullets in A condition, B condition, C and D. In A condition, when a person fire a bullet, the target is hit at center. So here we are getting the value very closer to the actual value. That's why these three darts are very accurate, but also they are also precise because these values having very less difference between them. So that's why these three values are also precise. Okay, so when you're getting your dart at center point, at closer point, then in this case high accuracy with high precision is maintained. Okay, now see in case B. In case B, what happened? The three dart hit the target center, but are not very close together. These three darts are hitting the center, means having value closer to the actual value, but having but these three values having some space between them. So that's why they are not precise. They are accurate, but they are not precise. Okay. In case of C, the three darts do not hit the target center, but they are very close together. In C case, they are not hitting at your target, but they are hitting at some place and having a very less space in between them. So this case is your called as the precision, highest precision case, but low accuracy. Okay, and in D case, the three darts do not hit the target at center, as well as they are not close together. Means they are not hitting at center, they are not accurate, as well as they are not precise because the gap between them is too far. So This is not accurate as well as not precise. So these are the four conditions: high accuracy with high precision, high accuracy with low precision, high precision with low accuracy, and low precision with low accuracy. Okay, so every time whenever we are working in the industry, we always use this concept of accuracy as well as precision. Okay, for the measurement. So this is all about your accuracy and precision. Now we will see the next property of a measuring device. Here we are going to explain some properties of measuring device. So the next property is your sensitivity. Sensitivity means what? Name itself indicates sensitivity. Means whatever input we are providing, how much output we are getting with how much rate. The rate by which the input is magnifying. It is known as sensitivity. See, sensitivity may be defined as the rate of displacement of the indicating device of an instrument with respect to the measured quantity. Means whatever input we are providing, by sensing that input, how much output we are given, how much displacement we are given. Like for example, in your thermometer, here in your thermometer, when we provide the input, we put it in our mouth for the temperature measurement. So it sends the temperature of our body and indicate on the scale. So that rate of indicating the displacement over the thermometer by sensing the temperature of our body, that phenomenon is called as the sensitivity. See, the sensitivity of thermometer means that it is the length of increase of liquid per degree rise in temperature. So by increase in 1 degree of temperature of your liquid, how much length that particular liquid should be displaced on particular scale, that is the sensitivity. Okay, so whenever we are going to measure temperature with the thermometer, the displacement shows the sensitivity of that particular thing. Okay, if suppose the device is under maintenance or failure, then it shows wrong displacement for your temperature measurement. Okay, in other words, the sensitivity of an instrument is the ratio of scale spacing to the scale division value. Okay, for example, of an dial indicator, a simple dial indicator, there is simple dial indicator, the scale spacing is 1 mm. Okay, and the scale division value is 0.01 mm. Okay, so in between 1 mm, the scale values divisions are 0.01 mm, then sensitivity is your 100. Okay, so it is a ratio of your scale spacing to the division value. So scale spacing is 0.1 and division value is 0.01, then your sensitivity is 100. So it is called as the amplification factor or gearing ratio. You can see on your scale there are lines, 1 mm line in between the 10 centimeter. So that indicates your sensitivity. Now the next property is your readability. It itself, its name indicates what is readability. Readability means ability to read the things. So readability refers to the ease with which the readings of measuring instrument can be read. Okay, how much easily we can read the instrument, that is the readability of that instrument. Fine and widely spaced graduation lines improve the readability. Means if there are fine lines or widely spaced graduations are provided over the particular instrument, so we can easily read the instrument. So in case to make the micrometer more readable, they are provided with vernier scale or magnifying devices. So in order to read the instrument properly, in some case they are provided with vernier scale magnifying devices. Okay. Now, the next term that we are going to discuss is here calibration. The calibration of any measuring instrument is necessary to measure the quantity in terms of standard. So means what? Calibration is the sorry. If we are going to measure anything with the help of instrument, then we adjust that instrument to the zero value, because for zero input it shows zero output. So by using that we can calibrate the instrument. Okay, it is carried out by making adjustments such that readout devices produce zero output for zero. Here one example is given. The process whereby the magnitude of output of measuring instrument is related to magnitude of your input force driven to the instrument. Means what? For our sake of purpose, we are not going to measure the actual reading. We just calibrate things by adjusting the value as per our requirement. Okay. For example, suppose you have to measure a 5 kg of weight, then you can simply press the zero and simply remove everything from that particular weighting machine. That weighting machine should be free to air only. Then press the zero, means it is set to zero. Then we measure the thing for our sake of variance. So whatever we are going to measure, that is calibrated from zero. The best example for the calibration is here when you are going to the petrol pump for filling your petrol or diesel. Every time after filling a fuel in particular vehicle, they again press zero, means they are setting to the zero value. If suppose they are not pressing zero, then what happens? The reading will continue from the point wherever it is stopped. Suppose a one person fill 100 rupees petrol in his bike, then if the person is not pressing the zero button, then the next one coming to fill the petrol will read the thing from 100. Okay, so always we have to set the parameters to zero for the calibration purpose. So it is just for our sake of convenience we are going to calibrate the things. Okay, the accuracy of instrument depend upon the calibration. The output of measuring instrument is linear and repeatable. It can be easily calibrated. Now, the next property is your magnification. Magnification is a simple process of enlarging something, only in appearance, not in physical size, so that it is more readable. For our reading ability, in order to improve our reading ability, we magnify things by enlarging. In physical, that parts are not actually magnified. By with the help of magnification glass or any devices, we just magnify the things. Okay, so this is one of the property. Then repeatability. Repeatability means what? It is the ability of measuring instrument to repeat the same result for measurement for the same quantity. The same measurement are carried out by first with the same observer, second the same instrument, third under the same condition, fourth without any change in location, fifth without change in method of measurement, sixth the measurements are carried out in short intervals of time, and okay, so repeatability is the property. So under the same condition, observer, instrument, condition, location, and measurement thing, we are getting the same result, same result. So that is known as repeatability. These all the property you just have to know that that properties are not going to ask in your examination, but while working in the industry, while actually working in the industry, you are facing the problem. So in order to avoid this problem, you must have a knowledge of this property. So just a basic part. I just want to cover this basic part before going to start your actual points. Okay. It may be expressed in terms of depression, dispersion of result, reproducibility. Similarly, from the reproducibility, reproducibility is the closeness of the agreement between results of measurement, the same quantity when individual measurements are carried out by different observers by different methods. Like repeatability, reproducibility is the closeness agreement for the measurement, but in this case, with different observers, different methods, we are calibrating the instrument under different condition, different location, and different. Okay, so let's see the new topic, that is error in measurements. This is a very important topic. One in the last question paper, last year question paper, one question was asked on this topic, that is explain systematic error and random error in details. So this topic is very important for your exam point of view. So just we just see what is the error in the measurement. What is meant by error in the measurement? Whatever we are going to measure, whatever we are going to manufacture, we measure that part. So each and every time when we are going to measure the parts, it shows some difference in the value. So that difference is occurred just because of the error during the measurement. If suppose there are five people measuring the same product at that time, if there is a single product, the single instrument, but by changing the people, the value of that particular measurement is also changed. So it is happened just because of the error in your measurement. Okay, so let's see. It is never possible to measure the true value of a dimension. There is always some error. Okay, the error in the measurement is the difference between measured value and the true value. This is the right thing. Whatever is the true value, suppose 100 is the true value and we are measuring 99, then what is the error? That is 1. Okay, suppose there is a 100 mm length and you are measuring 99 mm, then 1 mm length is the error in the measurement. Okay, because the actual value never changes. Okay, and your measure value you are finding every time it is different value. So every time you are going to having some errors. So the source of error may be different every time. So we have to find which type of error and we try to eliminate that error. But 100% errors are not possible to eliminate. We can minimize the errors in the measurement by knowing the things how the error should be took place during the measurement and what are the different types of error. Okay, the error in the measurement may be expressed either as the absolute error or relative. So there are basically two types of error. One are the absolute error and second is the relative. Or one of the systematic error. Absolute error are also called as the systematic error. And relative error are also called as the random error. So there are two types. First is your systematic error and second is your random error. So the difference between systematic error and random error should be asked in your examination. This is a very, very, very important question. You have to write on your notebook or somewhere that prepare for this difference. What is the difference between systematic error and random error? Okay, let's see. Absolute error. Okay, so absolute error, there are two types here. Absolute error. First is a true absolute error, and second one is the apparent absolute error. So what is absolute and true absolute error? It is the algebraic difference between the result of measurement and the conventional true value. So algebraic difference, absolute true absolute error is the algebraic difference. And apparent absolute error means if the series of measurement measurements are made, then the algebraic difference between one of the result of measurement and arithmetic mean is known as the apparent absolute. Means if we take a single reading, then that time the algebraic difference is here between true value and measured value is absolute error. But apparent is we are going to measure 10 to 50 series of measurement, and your first your any reading, one reading, and the arithmetic of all many having some difference. That is your apparent absolute error. Okay. So how you can going to calculate your arithmetic error, that is not measurement here. Whenever we are going to solve the numericals, we will see how the arithmetic mean should be calculated. Okay. So just remind this thing. Apparent error is the difference between one reading and arithmetic mean of the reading. Okay. Now relative error. It is the question of absolute error and the true value or the arithmetic mean of various measure. So that part, relative error, we will discuss in an large value. Like in part of random error, we will see what exactly it is. So now these are some types of error given. So these types are different from your systematic and random error. The systematic and random error I will explain in next PPTs. But before that, you should know what are the also different types of error that should be occurred. First, static error, which includes reading error, characteristic error, environmental error. Second is instrumental loading error, and third one is your dynamic error. So there are three types: static, dynamics, and instrumental loading error. In static, reading error, characteristic error, and environmental error. Okay. So first, static error. These errors result from physical nature of various components of measuring system. There are three basic sources of static error. So whenever physical nature of various components is varies during measurement, that error occurs. So first is your reading error. See, this error occurs due to carelessness of operator. Simply, when you are going to read something, during that reading, you are not matching the lines with your particular measuring device. The error occurs is called as a reading error. That is the fault of operator. These do not have any direct relationship with other type of error within measure system. So it is just a due to carelessness of operator that error occurs. Second one is your parallax error. Parallax error arises on account of pointer and the scale not being in the same place. We can eliminate this error by having a pointer and the scale in the same place. So this error, parallax error, is occurs when the scale division on your scale, suppose the division on your scale are very small to visualize, and you are not properly matching that line with your particular product. These both are not in the same place. There is a difference of angle is occur. Okay, means you are not going to match this line, but you also have to match the plane of the particular line. Suppose you're you're measuring some part, explain with the help of y plane measuring device. So that case, that is occur is a parallax error. So in order to measure the length in your x place, you have to put your instrumenting device, measuring device in x plane also. So by this you can find out the parallax error. Wrong scale reading and wrong reading of the data. Inaccurate estimates of average reading, inaccurate conversions of unit and calculations. Okay. So parallax error is here also reading error. Then characteristics error. It is defined as yes, 1 minute. deviation of the output of measuring system from theoretical predicted performance or from nominal specifications. Linearity errors, repeatability, hysteresis are the characteristics error. If theoretical output is straight line, calibration error is also included in characteristics. Means what? In characteristics, your input are something different, but your output behave in other manner. Like suppose uh, the graph, this is generally characteristics are error measured in the terms of graphs or hysteresis. So that graph shows you if the graph is showing you the linear nature, but during the reading shows different value. Some readings are not on the graph, not on the linear things, then that type of calibration error is called as the characteristic error. Okay. Now environmental error. These errors result from the effect of surrounding temperature, pressure, humidity. So this is generally every time during the measurement in nanoscale, micrometer scale, you are finding this error, environmental error, due to effect of temperature, pressure, humidity, working conditions, also effect of that. So it can be reduced by controlling that load according to the specific. Okay. So most of the time in the quality control department, the temperature, humidity, and pressure is maintained. Okay. So you will get the proper results of the measurement. The second is your instrument loading error. So first that was the static error, and this in static error we will see reading errors, parallax errors, characteristics error, environment. Okay. Now the second is your instrument loading error. Loading error result from the change in measurement itself when being measured. Okay. So suppose we are going to measure something. The measure the measurable thing is changed during measuring, during the time of measurement. Suppose it is expand, suppose it is contract. So that expansion and contraction results in your loading error. Okay. The instrument loading error is the difference between the value of measurement before and after measurement. Okay. For example, a soft or ductile component is subjected to deformation during measurement. So suppose we are going to measure a component before deformation, and we are going to measure this part during the deformation. So obviously due to contact pressure of the instrument causes the loading error. The effect of this error is unavoidable because we always know the thing that everything subjected to the deformation that should be changed in length. So this kind of error loading error generally occur during the heat treatment processes. During the heat treatment processes, every time if you are putting something, if suppose you are going to heat treat 100 mm bar with the length of 20 mm, then after heat treatment you are getting 100 point or below 100, the diameter changes, your diameter getting reduced and the length should increase. That length is 20 points. So these cross-sectional changes are occur that are the instrumented loading error during the process. Then dynamic error. Dynamic error also called as the measurement error is the difference between the true value of measuring quantity and the value indicated by the measuring system. And if it is no static error is dynamic error is what it is the instrument what the measuring instrument. Okay, if you are measuring something, if you are suppose you are measuring 5 kg of material, so solid material, and the instrument shows that value or that value should not be static. Here, if you are going to measure the pressure of some system, and your pointer is flickering continuously, not statically, it shows very dynamic in nature results, so that errors are dynamic error. Okay, systematic errors and your random errors. So in your examination, these two types of error are very important. Two types of errors: systematic error and random errors. So see, systematic errors are also called as the controllable errors because systematic errors we can control up to some limits, but random errors cannot be controlled. See, these errors are controllable in both their magnitude and stress. This can also be determined and reduced. These are due to first calibration. Okay, so this first thing we should understand: these errors are controllable in nature and we can determine it and reduce. So calibration. The actual length of standards such as scale will vary from nominal value by a small amount. This will cause an error in the measurement of constant magnitude. Calibration error means during the calibration of instrument, if your measuring instrument is caliber and during this calibration, if the instrument measure is found that it is wrong, then your measurement is also wrong in that manner. Suppose calibration is a if your measuring instrument is not calibrated properly. Suppose it it is showing the value in plus and minus. Okay. Suppose you have to measure the hardness of particular thing. If your calibration instrument shows the hardness in plus manner every time in plus 1 HRC, and every time you are going to measure the things shows the 1 HRC value in plus. So you just have you don't have to remove this, you just have to calibrate the machine again and try to reduce the problem. So you can find out where is the problem and you can reduce it. Then atmospheric error. Again, atmospheric condition like difference in the temperature, pressure, moisture at the place of measurement from that internationally agreed standard values 20 temperature and 716 with pressure can give the rise to error if measured size of the compartment is what. In order to control this error, a standard was given that is 20 degrees Celsius temperature and 760 mm of pressure. In this atmosphere, you can calculate, you can measure the value with highest accuracy. Okay. Next is stylus pressure. Another common source of error is your pressure with which the workpiece is pressed while measuring. So stylus pressure means what? The comparator device by which you are measuring the roundness, the thickness of a particular device. We are use a stylus. So whatever the pressure inserted by stylus over that particular product, that stylus pressure should be adequate to measure. If you are pressing it more, then your value should be different. And if the stylus pressure is not adequate on that particular part, then again your value should be different. So your stylus pressure is adequate within the measurement. So again, we can set the stylus to 0. When we are going to learn about the comparators, I will show what is the stylus pressure. Okay, so this is all about your stylus pressure. Okay, variation, just go through it. It's simple thing. I already explained. The force applied by the anvils of the micrometer. Okay, so due to that, it is a pressure applied by a person during setting of that particular workpiece. That is a stylus pressure. Avoidable errors. These errors may occur due to parallax, non-alignment of the workpiece and the center, improper location of the measuring instruments, such as thermometer in sunlight while measuring temperature. So these are the avoidable silly errors. Then the second is your random errors. Random errors occur randomly and the specific causes of such errors cannot be determined. The likely source of this type of error: small variation in position of setting standard, slight displacement of lever fan in measuring instrument, friction measuring system, operator error in reading scale. So the small variation in position and slight displacement in lever, friction, operator errors. So these errors cannot be avoided. These are the errors that randomly occur and it is not controllable. It is not in our hand to control. That's why they are called as random errors. So these are the two types of errors. Systematic error having poor accuracy but random error having poor precision. Systematic error having definite causes and random error having non-specific causes. Two types of systematic error having reproducibility while random error having not reproducibility. This is the difference between systematic error and random error. Okay, so this is all about your lecture. So you should go through this PPT and you provide this PPT on your Telegram group. Go through it. If any problem, ask me. I will tell you.